we live? I think so. Maybe. I think we're live. Nice. Let's post this. Perfect. All right, so how we all doing? I hope we're doing well. So we're going to go over sections G, H, and I. What's up, Bob? G, we actually haven't really practiced too much of G throughout the class, but we're just finding the domain. And I don't mind how you guys go about and find the domain. I think that in general, we can use a graph to be able to find it and figure it out. So if we wanted to use Desmos to kind of help with that. So for example, let's try like number 5. So the square root, not doing anything, Bob, just chilling like a villain. Okay. So if you guys look at the graph here, this is number 5, the square root of 2x plus 1 over x. Now, if you notice here, it looks like we have this like asymptote looking thing. And if you guys remember from rational expressions, we have these asymptotes. So just looking at this, we can recognize that there's this asymptote here, but everywhere else at 0, but everywhere else there seems to be graph starting at -1/2. So there's no graph here all the way from -infinity, but then once I have 1/2, I have a graph from -1/2 to 0. There's nothing here at 0, and then it starts again from 0 to infinity. So I could write that out as from -1/2 to 0 union from 0 to infinity. And we can use our graph every single time to figure that out. Wow, I'm really popular right now. My phone's going crazy. Let me check that real quick. I just want to make sure. Sometimes I get like this. No, I know what it is. Okay. I'm finally getting my roof fixed. Can you believe it? Isn't it crazy that after all this time, it's finally going to get fixed? I worked things out with the other roofing, and they gave me a full refund, and it was great, and now I can move forward. It's awesome. But anyways, so I'm expecting a call from my roofer to set things up. But anyways, we can actually find this. Yes, it's finally going to grow out its hair for quarantine. Yep, you got it. But we can actually find this algebraically. We don't actually have to use Desmos or graph to figure things out. So let's look at that actual function. So we have the square root of 2x plus 1 over x. So to find the domain, we need to think about where our graph is undefined or doesn't exist. And we can kind of like break it into pieces to kind of figure that out. So for example, when I see this x on the denominator, I think to myself, I can't divide by 0. Because if I divide by 0, that's undefined. So I take the denominator, and you can set it equal to 0 and solve. Well, x is by itself. So I know that if I was just thinking about that domain restriction at 0, it can't be that value, but it can be everything else. Now there's one more restriction, and I'll give you guys to kind of think about it. Square roots. Think about it. What can we not have inside of a square root? Negatives, right? So I can't have the square root of -1 or -2 or -10. Now, granted, they are complex numbers, but in terms of real numbers, imaginary numbers are not a real number. So we have to say either it can't be these numbers, so it can't be these specific values, or we can isolate it and say it can only be these specific numbers. So the types of numbers that are allowed to be in a square root are 0 and positive numbers. So mathematically, the way that we say 0 and positive numbers is greater than or equal to 0. Because first, numbers that are greater than 0 are positive numbers, and then equal to 0, well, I'm allowed to have 0. So I'm going to say whatever's inside that square root has to be greater than or equal to 0. So now what we can do is we can solve for that inequality. -1 on both sides. Divide everything by 2. And so I'm going to get x is greater than or equal to -1/2. So I want to take this statement here, and I want to look at what that would look like on a number line. Now, what I'm going to do is I'm going to draw a separate number line, and then we're going to look at how those two things overlap simultaneously. So we said it's at, we'll say that if this is 1 or -1. So this right here is -1. So this right here, that's -1/2. Here's 0. So at -1/2, it's a closed circle since it's equal to, and it's everything greater than that. So now I need to see where does it exist both in the numerator and in the denominator. So starting here at 1/2, not numerator and denominator, wrong language, in both number lines, in the top number line and in the bottom number line. I don't know why I said numerator and denominator. I had rationals on my brain. So if we notice here, starting with this value, they're both the same. They overlap with each other. Now, it's an open circle here, so it means that they're actually not on top of each other there. And then all of a sudden, once we get past that open circle, they're all on top of each other as well. So if I wanted to look at that as a brand new number line, so it starts at -1/2, it goes to 0, but we skip 0 because it's not in both number lines, it's not solid, or it's not shaded in. And so if we notice, this shaded region is the exact same as my interval that I wrote down when I looked at my graph. So just know that there's two ways for us to do it. We can complete this algebraically, or we can complete this using the algebra or the graphing method. So we can do algebraic or we can do graphing. My recommended, I guess, use graphing unless you want to practice doing the algebraic, because we've pretty much practiced how do we find the domain using a graph. And actually in pre-calculus, we spend some time focusing on the algebraic aspects of finding the domain. So, but it might be good practice starting now. So any questions on any of these? And like I said, you can enter in them. Let's look at number 12. If I entered into Desmos x plus 2 over x squared plus 4. So even if I zoom out, it doesn't look like there are any asymptotes here. It's just solid all the way through from negative infinity to positive infinity. So my domain for number 12 would be negative infinity to positive infinity. When is this assignment due? That is a really good question. I actually just got an email about all of this. Let me reread it so I can give you the precise date. All of this is due Wednesday. Actually, sorry. Tuesday. So, no. Never mind. I'm sorry. Yes, Wednesday. Yes, Wednesday. Sorry, I'm getting jumbled with the AM PM stuff. So all this is going to be due Wednesday of next week, because I have to have all the grades in Thursday. So everything's going to be like the books are going to be in on Thursday, and basically I'm just going to go through and we completed all the work. I'm going to take the average of it, and if it's greater than the greater than the 80% threshold that the district laid out, then you get the grade bump, and then we go from there. So, but if you turn it in on Thursday, I won't have time to calculate everything. So, yeah, Wednesday. So then, therefore, Thursday I can get everything in. Okay. Any other questions on Part G? No problem, Maria. Okay. So now, for Part H, it says find the, and there's a typo here. I guess my dogs are outside, because I hear them barking. It says find the slope-intercept form equation from the following information, and then find the distance between the 2 points. So this is all the way back from integrated 1. The slope-intercept form is y equals mx plus b. And I think that's actually Chandler. Joey doesn't really bark too much. But we need to know a point, and we need to know the slope to be able to find it. Now, I personally, and I don't know exactly the way that they went around for you to be able to find that, but I like starting with this equation always. This right here, we call this the point slope formula. And the geniusness about this equation is you just need a point and a slope, you plug them in, and you're done. Now, because the problem actually says find the slope-intercept form, okay, that means that we have to, if we start with this one, we then have to write it like that. But we just need 2 pieces of information. We need a point, x1 and y1, and then we need our slope. So if we find those 2 values, you plug them in, you technically have your equation of a line, and now from there, all you got to do is just manipulate it. So looking at number 1, it says f of 1 equals 3 and f of 2 equals 5. Well, it's saying if you plug in this x value, you're going to get this y value. So there's my point. And that's the first one. If you plug in this x value, you're going to get this y value. There's my second point. So to find my slope, y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. You're going to get 2 over 1, which is 2. So this here, that is my slope. So now, taking that, and here's my point, 1, 3, I can plug it into this formula. So y minus my y1 equals my m times x minus my x1. Now that it's in this form, so I have my equation here. It's like my weird triangle star that I'm going on here. Now that I have my equation, I just need to get y by itself, because y by itself is your slope-intercept form. So if I distribute the 2, y minus 3 equals 2x minus 2, add 3, I'm going to get y equals 2x plus 1. And that's my value. That is the equation of the line. Like I said, yes, you could find the slope and then plug in the point for y and x to find b. Sure, that's great. The thing, though, is in calculus, we need to be comfortable with all three equations of the line. And it's much easier starting with the point slope and then manipulating it to one of those other equations as necessary. So that's the reason why I typically like to start with the point slope, because it just makes the rest of what we could possibly do much easier. But you're more than happy to, I think in integrated one, you guys just plug in the values for x and y and you get your b, blah, blah, blah. Like, that's fine in this instance. But just know, working towards the point, or working towards us being comfortable with the point slope and stuff, that's something that we practice in Precalc. That's why I call this the Precalc readiness. Yeah. All right, second piece, it says, then find the distance between the 2 points. So then we're going to use the distance formula. That's x2 minus x1 squared plus y2 minus y1 squared. So x2 minus x1, so 2 minus 1 squared plus 5 minus 3 squared. 2 minus 1 is 1. 1 squared is 1. 5 minus 3 is 2. 2 squared is 4. So you're going to get the square root of 5. And that is the distance. Any comments, questions on part H? Okay. Now let's look at I. So I, sine of pi thirds and blah, 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 that's all unit circle stuff. Remember we had that memorized and it was great doing those unit circle quizzes. So good. But we still need to know it. So sine of pi thirds on our unit circle, if you guys need to look up the unit circle, pi thirds, bam. My cosine is, 1/2. My sine is root 3 over 2. And so the sine value is the y. The x is the cosine. So then the sine of pi thirds equals root 3 over 2. And so we just have to look at where the angle is. And then just as a reminder, tangent is sine over cosine. So you just take the y value, put it over the x value, and you have your answer. Any questions on the unit circle stuff? And remember that this here, this is positive rotation, and then this is negative rotation. So clockwise is negative rotation, counterclockwise is positive rotation. Any last questions? Well, great. Thanks, guys, for showing up for this stream. I hope that it was helpful. go ahead and continue working on everything. Video of what? No stream tomorrow. So we're going to do J and K tomorrow, or on Monday. And then we're going to have L and M on Tuesday. And then that will give you guys time to get everything in by Wednesday. Well, you don't need to say just kidding. That's a great question. And you reminded me to tell you guys that there's no stream tomorrow. I'm trying to give you guys those 3-day weekends. You know what I'm saying? You know what I'm saying? But yeah. So we're going to go through on Monday. We're going to be going through J and K. So if you guys want to go ahead and look at that a little bit ahead, come up with some questions, or as I model a little bit of it, but we should be able to do most of it. There's a couple of those that are going to be kind of challenging, but it'll be good for you guys to think about. Great. Well, I hope you guys have a good weekend. Let me know if you guys have any questions. Just post it in Discord. Other than that, I hope you guys have a good one. I hope you guys are healthy. I hope you guys are well. And stay safe.